Let's pull back the curtain on something you do dozens, maybe even hundreds of times a day without even thinking about it. Clicking a link or hitting enter. It feels instant, right? Almost like magic. But behind that one simple action is an absolutely incredible and complex journey. So let's just ask it. What really happens in that split second between your click and a web page just popping up on your screen? Okay, let's dive in and actually trace that path from your keyboard across the entire globe and back again. The very first step in this whole adventure starts right there on your own device, inside a piece of software you probably have open right now. Yep, your web browser, whether it's Chrome, Safari, Firefox, you name it. Its first job isn't to go get the page. No siree. It's simply to understand the address you just gave it. This is the starting line for your request. Now, to find anything on a network as huge as the internet, you're going to need a seriously good addressing system. And here's the cool part. The internet actually uses two different kinds of addresses that work together perfectly. First up, there's the URL. We all know this one. It's the human-friendly address that we can actually read and type. Let's just break this example down. The HTTP bit, that's the protocol, basically the language the computers are going to speak. www.airindia.in is the domain name. It points to one specific computer out there. And travel-info.htm is the exact file we want from that computer. Easy enough for us, right? But here's the thing. Computers don't really do names. They love numbers, and that's where the IP address comes in. Think of this as the real, official, numerical address for that server. So how do we get from the name to the number? A system called DNS, the Domain Name System, acts like the internet's giant phone book, instantly translating the URL we type into the IP address the computer needs. And this right here is the fundamental rule of the internet. If a device, any device, wants to send or receive information, it absolutely must have a unique IP address. No address, no connection. End of story. So, our browser has the right IP address, the request is ready to go, but it doesn't just fly across the internet in one big piece. Oh no, the process is way more clever than that. Instead, your request and all the website data that comes back to you is chopped up into tons of tiny little pieces called packets. You can literally think of it like taking a really long letter, writing it out over 100 different postcards, and then just mailing them all at once. This slide just lays out the whole amazing journey of those data packets, so let's walk through it. First, your computer breaks the data into those packets. Then, each little packet gets labeled with a serial number, like postcard 1 of 100, and the destination IP address. Now for the wild part. The packets don't have to stick together. They can take totally different routes across the internet, all looking for the fastest path. That means they almost always arrive out of order. But that's where a protocol called TCP comes in. It's like a master mail sorter, using those serial numbers to put all the postcards back in the right order. And what if one gets lost? No problem. TCP just notices a number is missing and asks for that one packet to be sent again. It's a brilliant, self-healing system that makes sure you get the whole message. Okay, so we've made a connection. Packets are flowing back and forth reliably. But what language are the computers at each end actually speaking? They need a shared set of rules or protocols to understand each other. Two of the big ones you'll hear about are FTP and HTTP. If you're downloading a single, complete file, like a PDF or an app, you're probably using FTP, the File Transfer Protocol. But if you're loading a web page, you're using HTTP. It's specifically built to request and then assemble all the different parts, the text, the images, the videos, that make up a modern website. And here's the key takeaway. This foundation of addresses and packets and protocols, it doesn't just power websites. It is the bedrock for pretty much every single way we communicate online today. For example, remember early Twitter? It was nicknamed the SMS of the internet because of those super short messages. Well, every single one of those tweets was just a little piece of data, broken into packets, labeled with an address, and sent flying across that same global network, creating a brand new way of communicating called microblogging. It's the same foundation that powers all our messaging apps. It doesn't matter if it's a private, one-on-one instant message or a real-time group chat with a bunch of people. Under the hood, the process is identical. Each message is just data, packaged up and sent reliably using the very same system. So now that we've seen all the individual steps, let's zoom all the way out and look at the big picture.
What is this incredible system we've been exploring, really?
At its heart, the answer is so simple and beautiful. The internet isn't one single thing. It is a vast, interconnected network of networks, linking millions of smaller, private, public, academic, and government networks all together. And a few key pieces make this global network tick. You've got the hosts, that's all of our computers. You've got the communication media, the actual physical stuff like fiber optic cables and satellites. You've got your modem, which is your personal on-ramp to the system. And finally, your ISP, the Internet Service Provider, which is the company that connects you to this whole worldwide network. So think about it. From your browser to the URL to the IP address to the packets being shattered and then perfectly reassembled, all happening across a global network of networks, all of these physical pieces work together in perfect harmony to make that seemingly magical, instantaneous journey of a click actually possible. It's an incredible system that has completely changed our world, right? And that leaves us with a final, really exciting question. We understand the amazing architecture that powers our digital lives today. But as technology keeps speeding up, what new systems, what new ideas will shape the next generation of this global network? What will the click of the future even look like?